Hey guys, let's talk about permissions in this lecture. Permissions give you the ability to allow or deny access to content such as files or directories to the users of your system. So, for example, if you do not want user A to be able to access files created by user B, you will set the permissions on file in a way that user A will be denied access. Therefore, permissions provide a very important tool to secure your Linux environment. There are three types of user-based permission groups: owner, group, and others. Owner is the user that owns that file, which is by default the user that has created the file, but you can change an owner of a file as well. Group is a group that file belongs to and is by default the parent group of the owner of that file. Others is all other users in the system that are not part of the group of that file. Moreover, for each user-based group, there are three basic permission types. Read, represented by R or octal 4, allows you to read the contents of a file. Write, represented by W or octal 2, allows you to modify the contents of a file or directory. And lastly, execute, represented by X or octal 1, allow you to execute the file if it is an installer or a script file, etc., and view the contents of our directory. I'd like to highlight here that to view the contents of our directory, you need X permissions on that particular directory. Now let's get back to our lab system. If I type in pwd, you can see I'm in the home directory of my user. And if I type in ls-l here, I'll get a list of the contents of my directory in a long list format. Now, the first column represents the permission types. The third column represents the owner of that file or directory. And the fourth column represents the group that file or directory belongs to. Now let's create a file called sample file. Touch sample_file.txt. If I do ls-l here again, you can see once I've created the file, by default the owner of that file is the user that created the file, and the group is the parent group of the owner. Now let's have a look at the permissions. The first character denotes special permissions. The next three characters denote the permissions for the owner of that file. So the owner has read and write access. The next three characters denote the permissions for the group, which means every other user who is not an owner but is part of the group, labit in this case. So everyone who is part of the group labit has read permissions on this file, and everybody else who is not part of the group labit has read permissions on the file as well. Now this doesn't seem right, does it? So let's remove the read permissions from everybody else, and we can do that by typing in chmod. Now there are two ways to do it. We can add octal, or we can use this way. So what this means is I want to remove from group O, I want to remove permission R, and then I need to give it a file name. So let's first do it this way. And if we do ls-l, we can see that we were able to remove read permissions. Now let's add write permissions to group. If we use the same method, group is represented by G, owner is represented by U, and others is represented by O. So you want to do it for G, and what do we want to do? We want to add, so we'll use a plus sign, And what we not need to add, so we need to add write permission, so we'll use a w, and then the file name, so sample.file. So modify permissions for group and add write permissions on this file. So if we do ls -l again, we can see that we were able to add write permissions. Now to remove permissions we use minus, as we've used here. To add permissions we use plus. We can also add multiple permissions, so let's add read and write for others on this file as well. So we go chmod, for others we want to add read write on this, so we can do that by using this, and we can see now everybody has read write permissions to this file. Now let's have a look at how we can do these using octal format. So in octal format we need to give numbers, and if we go back to the slides we can see read is represented by 4, write is represented by 2, and 1 execute is represented by 1. So going back to the lab system, let's say we want to give owner read write access, so read is 4, write is 2, so 4 plus 2 6, we'll type in 6. We want to give read permissions to the group, and we can do that, so read is 4, so we'll do 4, and we want to remove every permission from others, so we'll go 0, and then the file name. If we type in ls -l, we can see we were able to achieve the desired result. Now let's create a directory. Called test. Let's cd into this directory. Let's create another one here called test1, and let's get out of it. And if we do ls -l, we can see this is our directory. Right now the owner has read write execute, which means owner can read the contents of a file inside the directory, modify the contents of the directory, and view the contents of a directory as well. Group can only view the contents of the directory and read the contents of a file inside the directory. Same for others. Now what we can do is we can now give the owner read write and execute, and let's remove everything from others. So chmod, and read write execute is 4 plus 2 plus 1, so read represented by 4, write represented by 2, so 4 plus 2 6, and execute is represented by 1, so 4 plus 2 plus 1 is 7, so 7. And let's keep the permissions same for group, so read and execute, so read is 4, execute is 1, so 5, and let's take everything out from others, so 0, and then the directory name ls -l. We can see, so we were able to achieve the result. However, if I go into test directory and do an ls -l here, ls -l, we can see that whatever we did here wasn't done recursively, so any files or directories inside this directory were not affected. Now what if we want to do a change like this recursively? So we want to make permission similar for any other file or directory that's inside the directory. So we can do that by using chmod minus capital R option on test directory, hit enter. So if we type in ls minus l, we can see that test has 7 5 0, and if we go inside test and do an ls minus l, we'll see test 1 also has 7 5 and 0. Now let's have a look at chown command. So if we go one step up, chown allows you to change the owner and group of the file. So if we type in chown minus minus help, we can see that the usage of that file is chown, options, owner and group separated by a colon. And we can also do that recursively, and we've got all other options as verbose, etc. as well. So let's do an ls minus l. So on test, right now the owner is Labbit and the group is also Labbit. Now let's change it to Labbit admin. So if to do that, we'll use chown Labbit underscore admin colon Labbit underscore admin, which is the parent group for Labbit admin, and let's give the file name. Now if I hit enter, let's see what happens. It says operation not permitted. This is because I need to run this as an administrator user. So if I do a sudo, then type in the password for Labbit. If I do ls minus l again, I can see that for test the owner and group were both changed to Labbit underscore admin. Now I didn't do it recursively, so the user Labbit should still be able to view the contents of test 1, I think. Not sure. So let's have a look if I can cd into this now. Permission denied because I'm not part of the group. Now let's do this. Let's change the group of this file by typing in chgrp, and let's have a look at help first. So chgroup allows you to change the group of file, and we can do it as chgroup option group and then file name, and these are the options, which means we can also do it recursively as well. So ls minus l again, sudo chgrp, and we want to change the group to Labbit, and then test, and we also want to do it recursively, so we'll do it like this. Type in ls minus l again, we can see that the owner is Labbit admin and the group that this file belongs to is Labbit. Let's see if we can access this file again. Yes. Why? Because Labbit is part of the group Labbit, which means these permissions r-x will apply to this user. So I can view the contents of this directory because I have x permissions on this directory, but let's see if I can make a directory within this directory. Permission denied. And this is just to test if whatever we did was done recursively. So you can see that the first change that we did, we changed the owner of this file to labit admin and the group to labit admin, and this operation wasn't done recursively, did not affect this directory. And the second change, the change that we did was done recursively, so it affected the parent and it also affected the second directory, but because the second directory was already part of the group labit, we can't see the change. Now we've seen that how we can change the permission types. We now know how we can change the owner of a file. We now know how we can change the group of a file. Let's have a look at some of the special permission types as well. The first permission type is D, and this signifies a directory. So if we look at this piece of information, we know this is a directory, and the preceding D will tell us that it is a directory. Dash means there are no special permissions associated with this file. Next is a symbolic link. A symbolic link will be used when you want to point your file to some other file in the system. So for those files will have L at the start rather than a D. So if we were to create a symbolic link, you do that using ls-l. You give file name, so let's give the file name as test1, or let's call it simtest, and let's give the symbolic link of examples.desktop. Sorry, ln-s. Oh, I'm in the wrong directory first, so let's get into the correct directory and try again. ln-s simtest examples.desktop. If I hit it's done the other way. If I now hit ls-l, so I can see that syntest is a symbolic link for examples.desktop, and the first character on the permission type shows L here. Now going back to the slide, the next is set user ID or set group ID permissions. What this indicates is that when you run or execute a file, execute it with users permissions or the group's permissions, and you set this by typing in, let's say we use test and we run it as owner's permissions. So chmod, owner is you, and you want to give it set uid permission. So we need to use sudo again. If we type in ls-l, we can see that under here for the owner's permission type section, S was used. That means we are using special permissions set user ID here, and when this will be executed, this will be executed as the owner, which is labit admin. Now the next bit is sticky bit, and sticky bit is used when you're working in a shared environment. And what this does is, so let's say you've got a directory and you've got files within that directory that are owned by multiple file owners. A sticky bit permission will allow you to make sure that only the file owners can rename or delete their files. Now let's see how we can add sticky bit permissions. Let's say we want to change sticky bit permissions on test. We'll do that by typing in chmod, and we want to add sticky bit permissions plus, and I'll say T. I'll give it the directory name. I always forget I have to do it using sudo. If I type in ls-l again, I can see that T was added to this directory, telling us that it has sticky bit permissions. This concludes the lecture on permissions. Thank you for watching. I will see you in the next lecture. Bye.